since we have reversed A, then we need to invert each element of A. So I'm going to say I think what I'm going to do is just, I'm tempted to do mapcar inverse all of A, or all of reversed. But I'm thinking about not doing that because this will lead to an invalid sort of, it's not going to canonicalize it. It might be necessary for me to at some point write a function that can canonicalize the elements. So I'll do this, and then I'll use, I think I have Alexandria loaded, Alexandria flatten this. So first I'll show you what I mean first by not doing that, what happens. If I say, let's say inverse, free, compose, free, 1, 2. Let's do this in steps. So compose free, what did I do? Return this. I'll compile this. Make sure this is compiled and this is compiled. What am I? Oh. It's erroring up here. Free group num elements. Oh, of course. G. Okay, good. Yeah, I think a canonicalized function is probably good. I'm gonna define canonicalize free group element. Some element E. I'll pass in G as well, and I'm just going to use Alexandria flatten B. Ignore G. So this, where did I do the? Okay, so if I do this, and if I do inverse of this, let's see what it looks like. Free and return the sign stuff. What am I doing wrong? Oh, because I'm not passing here lambda E inverse G E. All right, so this works fine. So it works when the elements are like this, but let's suppose that I do, let's suppose I do something like group element of something like this. Well, that's definitely totally wrong. Let's look at what. Oh, because I'm not passing G. I should really check for that as well. Check type G as a free group. So free here. Okay, so, oh yeah, because that function flattens it. Let's do compose with free group element of our free group with 2, 1 or something like that. And it still does it fine. So inverse, let's see, compose. Okay, so maybe this does work if we, because I'm trying to think if there's any way that we can, assuming that our elements passed to compose are themselves, or passed to inverse are themselves a a properly created thing by way of using compose and so on, then the result seems to be just fine. So let's see, compose 1 with, yeah, okay, so that's a palindrome. Let's actually check that this is inverted. So if we do 3 here, then yeah, we get -3 in the back. Or we can do like -2 here, and so on. Okay, so this code is a little bit sloppy, but I'll clean it up a bit after, and I want to move on to trying to represent so-called straight line programs. Actually, before I get to that, I'll clean it up a little bit. So oops, my Emacs bugged out a little bit. And so free group, and now we can take this thing out here, and we should spell it out: element, and so on. And change this to this long free group element valid p. So we have this. We can take out this thing right here. And then, so this is, I should do this free group element valid p. That looks good. And then here we can just do assert free group element valid. This is actually going to be buggy. I need to fix this after I type this thing down here, because my free group element valid p now takes a group as an argument. G of A, and we'll say A. So take this, make sure that we assert that B is also valid, even though it will get checked in this free group element function. We'll just keep these sanity checks here because it just makes debugging so much easier. Anyway, like I said, I need to change this, both of these now, to be lambda E, and then a call to this with the group G and E. And then same with this one. So I'm just going to copy this and yeah, I might factor that out and have it as a part of the protocol. I'll have to think about that. I mean, it seems like it might be nice. Yeah, I'll think about it. I'm trying to think if that would be useful useful more generally because I don't really have it in my other group code. I'll have to think about it. I'll write it down as a possibility. Because this code, like this repetition rate, I mean, it's a little bit ugly. And what would especially be nice, yeah, I'll think about it. So I'm worried about this code because it doesn't actually ensure that things are canonicalized, but I guess it doesn't hurt to just put a canonicalization thing here anyway, in case the implementation of this function itself changes. Canonicalized. It's just not obvious from the code itself that this will be canonicalized group element. What do we have? Oh, I didn't compile it. Canonicalized. Oh, I could give a element G. And I don't know if G itself should be, or I don't know if canonicalization should be part of the protocol either. But we'll see. Okay, so now I want to get into straight line programs. So first, what is useful about this whole free group business? The utility of a free group is it actually has utility outside of computational computational group theory. But the way I see it, the most utility that you get within this, within computational group theory from a free group, is it allows us to identify elements of a group, specifically elements of a group that's generated by some set of generators. It allows us to identify them in a sort of succinct and compact way. Since the free group is indeed a very free structure, it's mostly concatenation, we don't have much information loss. There's not a lot of structure that a free group provides. So it's useful since it's mostly structure preserving. You can almost look at a free group as a lazy group almost. If we define a homomorphism between a free group and some other group, like a permutation group or a matrix group, then you can work with elements within the free group that almost, like I said, they're almost lazy. And only when you compute the homomorphism, the image of some element in the free group, into your target group, will it actually get computed to its final element. So that's kind of the utility that I see of free groups. But there's one aspect of free groups that does not remain very lazy. There's one element of free groups that does not remain lazy, and that we can very, very clearly see this by all this sort of nonsense we're doing with canonicalization and so on. In a free group, if I do like inverse our free group, and then we do a free group element, free 1, 2, 3. I don't think I recompiled everything. I'm just going to recompile the file, and I get something that's an error. So we see here that immediately when we ask for the inverse, it's a very strict operation. We have 1, 2, 3, and the result itself is -3, -2, -1. So it was a very immediate computation. That's not necessarily bad, it's just kind of violating this property of free groups that I've been talking about, which is the sort of laziness aspect of them. Sometimes we do actually want laziness. In fact, I specifically want